Welcome to Abstracts, a Microsoft research podcast that puts the spotlight on world-class research. In brief, I'm Amber Tingle. In this series, members of the research community at Microsoft give us a quick snapshot or a podcast abstract of their new and noteworthy papers. Our guest today is Weizhu Chen. He is Vice President of Microsoft Gen AI and co-author of a paper called Not All Tokens Are What You Need for Pretraining. This paper is an oral presentation during the 38th Annual Conference on Neural Information Processing Systems, also known as NeurIPS, which is happening this week in Vancouver. Weizhu, thank you for joining us today on Abstracts.
Thank you for having me, Amber.
So let's start with a brief overview of your paper. In a couple sentences, tell us about the problem your research addresses and, more importantly, why the research community and beyond should know about this work.
So my team basically in Microsoft Gen AI, we are working on model training. So one of the things actually we do in the pre-training, we realize the importance of the data. And we found that actually when we do this kind of the data for each of the tokens, some token is more important than the other. That's one. The other one actually is some token actually is very, very hard to be predicted during the pre-training. So for example, just like if someone see the text of a Weizhu and what's the next token, it can be Chen, it can be any of the last name. So it's very hard to be predicted. So, and if we try to enforce a language model to focus on this kind of the hard to predict token, just like actually it's going to confuse the language model. There are so many different kinds of the example like this, just like, for example, the serial number in your UPS. So the focus of this paper is try to identify which token actually is more important for the language model to learn. And actually the other token maybe is just a noise. And how can we try to discriminate the token, which is good token, which is noise token. Basically, you try to understand this kind of the dynamic of the tokens.
How did you conduct this research?
Actually, we do a lot of work in the model training, including the pre-training and the post-training. So for the pre-training side, actually, the most important thing to us is the data. We also try to understand how can we leverage the existing data and how can we create much more data as well. And data basically is one of the most important things to build a better foundation model. So we try to understand how much more we can get from the data. And the important thing for the data is about the data filtering. So you think about actually in the previous literature, we do the data filtering, for example, just like we build a classifier to classify, okay, this page is more important than the other. And this page actually is a noise because there's so much noise data in the web. So we just keep the best data and to get into the pre-training corpus. So, and further away, we think about, okay, yeah, so this is maybe it's no final grain enough. So can we try to understand even for the same page we want to keep? So some token is more important than the other. Maybe some token is just some noise token. Actually, you put this data into the pre-training, it's going to hurt the model quality. So that is the motivation actually we try to think about.
And what were your major findings?
Our major finding is about basically, definitely, this works so well. And it's so important that actually we are able to get the best token from the corpus and then make it available and try to ask the model during the pre-training to ignore the token we don't want to get into the model itself. So that is one. The second thing, definitely, data is the other very important thing. If you're able to figure out the better way to build the better data, is most likely you're able to build a much better foundation model. The third thing actually is also connected to a lot of other existing work, just like data synthesis, just like distillation, just like data filtering. And so a lot of things are very connected together. And actually, this work basically, you can associate with also a lot of other work we are working on, just like distillation. You can think about, for example, for this work, we also try to build a model, a reference model, we call it as the reference model, to try to identify actually this data, this token is more important than the other, and try to understand the discrepancy between the reference model and the running model, their prediction on each tokens. So you can think about also it's some kinds of the try to distill from the reference model to the existing model as well.
Let's talk a little bit about real-world impact. Who benefits most from this work, and how significant is this within your discipline and even downstream for people using applications?
This actually is very, very fundamental work because just like I shared a little bit before, actually we build the data, and this data we build the data much better. It's able to build a much better foundation model. It will able to build a better model. Actually, it's able to benefit so many different kinds of application. This also is going to help us to build a much better small language model. And we can also serve this model even in the edge side, in the client side, in the coding scenario. So we are going to see actually huge impact from this kind of foundation model if you are able to benefit from building much better training data.
Are there any unanswered questions or unsolved problems in this area? What's next on your research agenda?
Yeah, I think that is very good questions. And definitely there's a lot of things about how to build a better data is unsolved yet in the literature. And especially because when you do the pre-training, the most important part is the data. But the data is very limited. And how can we make better use from the existing limited data is a big challenge. Because we can increase the model by 10x, but it's super hard to increase the data by 10x, especially when we want to deal with the high quality of data. The other way, even given the data, how can you identify, especially for this work, the importance of each token to build a much better model? I think all these things are very connected together. To me, actually, data is the oxygen. So there's so many things we are able to do in the data, including building for the either small language model or the large model.
Data is oxygen. I love that. So other than that being a key takeaway, is there any other one thing that you'd like our listeners to walk away from this conversation knowing?
I would love to say actually focus more on this kind of data and focus more about how can we get more from the data. Actually, it is the very important thing. And the other thing, actually, we are working on something that's very exciting. You can feel free to come to join us if you are very interested in this area.
Well, Weizhu Chen, thank you for joining us today. We really appreciate it.
Thank you. Thank you for having me.
And thanks to our listeners for tuning in. If you'd like to read the full paper, you may find a link at aka.ms/abstracts. You can also find the paper on archive and on the NeurIPS conference website. I'm Amber Tingle from Microsoft Research, and we hope you'll join us next time on Abstracts.